both either in terms of sine or cos. So I will consider this, the value of x2, which is there as 4 cos of omega t plus 10 degrees in terms of sine by adding 90 to 90 degrees. So it becomes 4 sine of omega t plus 100 degrees. So now x1 is also in terms of sine and x2 is also in terms of sine. And we know what is the value for the x. That is nothing but the addition of two harmonic motions, that is x1 and x2, and the value for x is 9.42 into sine of omega t plus 76 degrees. X is equal to 9.42 in sine of omega t plus 60 degrees. So let us understand how to prove it graphically or how to solve it graphically. So first procedure is draw the axis, that is nothing but OX and OY axis. So after drawing the OX and OY axis, then consider the amplitude and angle given for x1. The amplitude is A and alpha is 60 degrees. And for x2, this is, I will call it as A1. A2 is 4 and alpha 2 is 100 degrees. And the final value of A is 9.42 and the final alpha value is 76 degrees. So first what you have to do is, first you have to draw a vector x1 with an amplitude of 6 and angle alpha with 60 degrees with the OX axis. So it means first at an angle of 60 degrees, because the first one is 60 degrees, the amplitude is 6. So at an angle of 60 degrees, draw a line of length 6 centimeter. First draw a line with an angle of 60 degrees with a length of 6 centimeter. Because amplitude is 6, the angle is alpha is 60 degrees. So I will call this as 60 degrees with the axis OX, and I will call this point as B. I will call this point as B. Then next, draw x2 with an amplitude of 4 and angle of 100 degrees. So from O, draw a line with an length of 4 centimeter at an angle of 100 degrees. So I will call this point as D, and this angle is 100 degrees and length is 4 centimeters. So this is x1 and this is x2. This is x1 and this is x2. Now from B, so wherever this point B ends, that is of 6 centimeter line, from B draw a dotted line parallel to OD. So parallel to OD, I am going to draw a dotted line. Similarly, from point D, where it ends at a distance of 4 centimeter from point O, draw a line parallel to OB. Draw a line parallel to OB. So both the lines are going to intersect at a particular point, and I will call this point as C. Wherever these two dotted lines intersect, I will call that point as C. Now wherever the point C is there, from point C, join the line to O, and this is going to give us the resultant x value, that is nothing but, this line is nothing but, that is for x is equal to 9.42 into sine of omega t plus 76 degrees. If you measure the angle with OX for the resultant line, the angle will be always 76 degrees, and if you measure the length, it will be equal to 9.42 centimeters. The resultant line length will be equal to 9.42 centimeters, and the resultant angle will be 76 degrees, and that is going to represent the addition of two harmonic motions, that is nothing but the resultant harmonic motion, that is nothing but x is equal to 9.42 into sine of omega t plus 76 degrees. So by that graphical method, we have proved that whatever the value we have got for A by analytical method, that was 9.42, and when I solve it graphically, I found out the length of the line is 9.42, that is nothing but that is going to represent the amplitude value. And also analytically I have seen the value of alpha as 75.838, and by solving graphical method, if I check the angle for the resultant, the angle is going to give us 76 degrees from the axis x. So it means that whatever we have done analytically, that has been proved graphically. So analytical method, whatever the results we have got, the results were correct, and it has been proved graphically also, and we have checked that both analytical and graphical methods would give us the same results when we add two harmonic motions. So this completes the first problem on addition of harmonic motions. Yesterday we have seen the derivation, and today we have done one problem. So now let us solve another problem on been asked in the VTU exams as well as your autonomous SW exams. If you go through the question paper, every time there was one question in your VTU question paper as well as SW question paper on addition of harmonic motions. So let us solve the second problem, problem number 2 for today's class. The problem statement is, split the harmonic motion x is equal to 10 sine of omega t plus pi by 6 into two harmonic motions one having a phase angle of 0 and the other of 45 degrees. So it is a little bit different problem statement compared to the previous problem. In the previous problem, the values of x1 and x2 was given to us. Is it clear? In the previous problem, what is the change was, the values of x1 and x2 was given to us, and we used to assume the value of x, and we used to say that when we add two harmonic motions, the resultant motion will also be a harmonic. So we used to choose the value of x as a sine of omega t plus alpha. But in this case, what they have done is, as 3.67 at an angle of 0 degrees, and I will call this point as B. I will call this as x1 is equal to 3.67 at an angle of 0 degrees. Then next, what is given? Next one is x2 at an angle of 45 degrees and the length is 7.07. So at an angle of 45 degrees, draw a length of x2, that is nothing but x2 is equal to 7.07 at an angle of 45 degrees, and I will call this point as D. I will call this point as D. Then what is the next procedure? From point B, draw a line parallel to OD, draw a dotted line parallel to OD. So the line will be like this, which is parallel to OD, and also from point D, draw a line parallel to OB. So line parallel to OB. So I have drawn. The next, I will call this point wherever these two dotted lines intersect. So I will call this point as C. Wherever these two lines, dotted lines intersect, I will call that point as C, or you can call any point. Then draw a line from the intersection point till origin. That is going to give us your resultant. So this is going to give us the resultant, and if you measure the angle will be equal to 30 degrees, and this into the equation of x, so you are going to get the resultant equation. Then that is the first type, and in the second type, what they are going to do is they are going to give directly the resultant motion. They are directly going to give us the resultant motion, and we need to find out what are x1 and x2. They are going to give us directly the value of x, because we know that x is equal to x1 plus x2. We know that x is equal to x1 plus x2. They are going to give us directly value of x. In the previous problem, x1 and x2 was given, x we have assumed and we have found out. In the second problem, they have given x1 and x2, but they have not given what is the value of x. So we need to find out x. In the first problem, x was not given, x1 and x2 was given, and in the second problem, x is given, x1 and x2 is not given. That is, split the harmonic motion. We need to split the given harmonic motion into two harmonic motions as x1 and x2, and once again we need to solve it, and we need to find out what is the value of A and B, so that we can find out the value of x1 and x2. Then go for the graphical method. First draw the axis OX and OY, then draw the amplitude for x1, whatever it is, whatever the length is given with the particular angle, then draw amplitude A2 with the given angle, then draw parallel lines from both the points, and wherever they intersect, the point will be the intersection point. Join that intersection point with origin. You are going to get the length of the amplitude as well as the resultant angle. And if both are going to match, then it means that whatever you have done, it is correct. So here one thing is clear: whatever analytical method, whatever you have followed and whatever the values you have found out, if it is not matching with the graphical method, it means that you have done the mistake, either in the analytical method or in the graphical method. So it is just like a self check. In the examination, directly will come to know whether it is correct or wrong. And these kind of problems will be asked for 8 to 10 marks. These kind of problems may be asked for 8 to 10 marks. If it is 10 marks problem, then 7 marks will be for analytical method, or 6 marks will be for analytical method, and 3 to 4 marks will be given for graphical method. And if it is asked for 8 marks, then 6 marks will be for analytical method and 2 marks will be given for graphical method. So maximum marks will be given to analytical method and minimum marks for the graphical method. So this completes the problems on addition of harmonic motions. So it is not necessary to solve many problems on this particular topic, because it is a procedure oriented and it is very simple. So in the book, another 3 or 4 problems are available. So you can go through those problems, if you have any doubts, you can call and you can clarify your doubts, and we will be there to clarify all your doubts. Anytime you can call us and clarify your doubts. So this completes one bit of this chapter, and the next bit is completely different. That is where we are going to make use of the equations of motion, and we are going to find out what is the frequency, what is the natural frequency of any particular system. So for that, 3 methods are there: energy method, Newton's method and Rayleigh method. So first we'll discuss the different methods, and then we'll go for solving of the problems based on those 3 methods. The problems are very easy, but you need to understand the procedure clearly and you need to understand the concept, so that you can clarify the problems without any difficulty. So this completes the topic on addition of harmonic motions. In the next class, we'll start with derivation of differential equations using different methods. So 3 methods: Newton method, energy method and Rayleigh's method. So by solving 3 methods, after going through 3 methods, we'll solve the problems on equations of motion and also to find out the natural frequency for a system. This completes the first bit of this chapter. In another 3 or 4 classes, we will complete this chapter and we'll move to the last chapter. Thank you. If you have any doubts, you can call us and you can clarify any of your doubts. And whatever the first 2 classes I have covered, so that has been already uploaded on your aeronautical YouTube channel. So please go through the video, and if you have any doubts, you can clarify. Thank you.